Welcome back. Today we will discuss how overload control will be provided inside an SPC exchange. So stored program control exchange needs to provide overload control. So a processor inside an SPC exchange can handle only a finite number of calls. So the processor system has only finite capacity. So there is a limit to the number of calls that an exchange can handle within a particular duration, that is for per hour, that an SPC exchange can handle successfully. So the capacity of an exchange is therefore specified in terms of its what is the number of subscriber lines the exchange is connected with and the traffic offered to the exchange in Erlang and the number of busy hour call attempts that it is observing within a particular hour. So busy hour call attempts generally defined as BCHA. So with these three parameters, what the number of subscriber lines that this exchange SPC exchange is connected with and also offer traffic and the number of busy hour call attempts it is handling at that particular 1 hour time duration. So that defines how able the exchange is, what will be the capacity of an exchange is. So let us consider one example in which we are dealing with System X local exchange and it is observed that it can accommodate up to 60,000 line terminations. That means 60,000 end users or customers can be connected for this System X local exchange. Not only that, it can handle 10,000 Erlang of traffic. It can handle 10,000 Erlang of traffic, which is very large, and also it can handle 5 lakh busy hour call attempts. So it is somewhat very large. So that is 5 lakh busy hour call attempts can be. So these three parameters defines how able the System X local exchange is, or what will be the capacity with respect to the SPC local exchanges can be observed. So let us assume the processors used inside an SPC exchange can handle n number of calls per hour. If n number of calls are supported by an SPC exchange, then of course the throughput of calls per hour would be equal to the number of calls offered until this reaches n. So let us consider the scenario in which we are explaining the overload control facility provided by our SPC exchange. So as you goes on increasing the traffic, or if you goes on increasing the number of calls offered for an SPC exchange, so we know an exchange will be having its own maximum number of trunks that are connected to, or the maximum number of servers that are connected to. So depending upon the links that are going out from an exchange to another exchange, so the number of calls supported by an SPC exchange can be decided. So please note that right now we are assuming the number of trunks that are available with respect to our SPC exchange is n. So and the number of calls are being increased from smaller value to larger value. So as you observed, there exists a linear relationship between the calls per hour carried or supported by an SPC exchange. So as you with respect to calls per hour offered for that particular exchange. So as you goes on increasing, and when the number of calls offered for that exchange is n, we observe the number of calls carried by the exchange to be also equal to n. But with respect to our idle system, so we are dealing with idle system in which so many number of processes are involved with respect to a particular SPC exchange, and all processors are taking equal number of calls. Let us assume like that. So with respect to this, if you increase or if you provide or if you offer more number of calls for this SPC exchange greater than n, so and we know since the number of trunks are n, this exchange cannot handle more number of calls. So the maximum calls that an SPC exchange can handle will be becoming exactly equal to that of n. So and of course if you goes on increasing the number of calls offered for an SPC exchange, of course it cannot go beyond this value n and it will be constant. So number of calls handled by the system becomes constant, and that is shown in this plot A, and that is shown in this plot A. As defined, as the number of calls offered per hour increases, throughput of successful calls is going to become, or it is going to remain constant, that is at n, that is shown in this curve A. But in practice, some processing time is utilized by unsuccessful calls as well as successful calls. So we know when we are applying certain calls to an SPC exchange, few calls will be processed and few calls will be moved to queue. So whichever the calls that are moved to queue can be said as unsuccessful calls, and whichever the calls which are processed by the system can be said as successful calls. It is clear that both successful calls as well as unsuccessful calls are going to use processing time of our SPC exchange. So of course processors of our SPC exchange must be given for both unsuccessful calls as well as successful calls. If the calls offered for an exchange exceeds beyond n, so in such case some calls are going to become unsuccessful. So please note, these unsuccessful calls are going to use processor of our SPC exchange, that is they are going to use processing time. So the number of successful calls that is supported by our SPC exchange is going to become less than n in our practical cases, whereas that was not the case in ideal case. That is in our ideal system we used to have maximum number of calls to be n, but in our practical case, since as the number of calls are more than n, few calls are going to become unsuccessful. As the number of unsuccessful calls goes on increasing, the processor's time utilized by unsuccessful calls is also going to increase. So the number of successful calls is going to decrease and decrease and decrease with increase in number of calls offered for our SPC exchange. So that is what the case observed in practical SPC exchange. So that is shown in curve B. So as the number of offered calls increases further, that is beyond n, the number of unsuccessful calls is also going to increase, and the throughput of successful calls also decreases. So as shown in curve B, so the throughput of successful calls is going to decrease. So please note that since the number of successful calls are decreasing, so this is going to be a disadvantage for our SPC exchange. So what we do is, so to prevent this unwanted behavior, we are providing overload control. So overload control is introduced inside our SPC exchange. So with the help of overload control, we are going to restrict the amount of traffic that is offered for the processors inside an SPC exchange. So these processors are going to handle the load or the traffic that we are applying. So what we do is, with the help of overload control, we will decrease the amount of traffic that is offered or that need to be handled by the processor inside our SPC exchange. So by rejecting some of the traffic offered to the exchange, so what we do is we will reject the extra traffic that is appearing into our SPC exchange. So we will reduce this traffic. So consequently, as shown by curve C, the throughput of the exchange is going to remain at its maximum level, even though the number of calls increase beyond n per hour. So as you can see here, let us call this as curve C. So please change it as C. So as even though we are increasing the number of calls offered, so the number of successful calls is going to remain constant. Of course, it is not going to become equal to n, but of course less than n. But instead of decreasing, we are able to maintain this number of successful calls to be constant, even though we are increasing the offer traffic to our SPC exchange. So this is made possible with the help of overload control. Of course, overload control will remove the extra load that is offered for our processors inside our SPC exchange. So basically, the overload control program, so whatever the overload control facility that is provided by SPC exchange is made possible with the help of overload control program. So this basically monitors the number of calls that are waiting inside the queue for processing. So as the number of calls inside the queue progressively increases more and more, and if it is reaching to a maximum level, that is predetermined level, so it is going to perform, overload control program is going to perform three different functions. So the first action is to discontinue background tasks such as routine maintenance programs. So routine maintenance programs will be made. So generally inside an SPC exchange, in background, so many routine programs will be performed. So those routine maintenance programs will be halted or paused, and so those processes are given with the calls that need to be handled. So next, a proportion of new calls is rejected. Whatever the extra calls, as we goes on increasing the number of calls into the system, of course the extra calls are stored inside the queue. So as the number of calls goes on increasing inside the queue, a proportion of new calls is rejected. So we stop taking new calls into this queue, and finally all calls will be rejected once it reaches its threshold, predetermined threshold. Once the queue has reached its maximum level, maximum number of calls to be handled, so it will not take any extra calls. Extra calls will be rejected. Of course, if there are any emergency services calls, something like 100, 101, 102 or 108, so such calls will be processed by our SPC exchange. So the processing of existing connections is not discontinued. Whatever the calls that are already available, so those calls will be maintained. So those calls will be processed. The extra calls, whatever the extra calls that are coming, so those extra calls will be moved to queue, and of course the queue has its own threshold level beyond which it cannot handle. So those calls will be rejected or removed from the system.